How you doing today? Hopefully all right. Working through these problems on quadratics, discriminants. This problem looks like it's one of those multi parts to the problem. Sometimes those cause me a little bit of trouble. Get them all right. That's all right. We'll be determined and keep being disciplined at figuring it out. We're working in algebra 2. Lesson 2.6, we're on the last question. I always say that's the one I was looking for. Once I get it done, anyway. So the height of a ball is given by this formula. S is the height. I never have understood why they use the letter S, but oh well. I think it's a Latin word. So you have that T is the number of seconds after it's thrown up. The initial speed, you might notice that initial velocity is always in there right there. The height from which it's thrown, that's your y-intercept. Then this negative 16t squared, that's the gravity coefficient that's used because of how gravity affects. So anyway, after you have that formula A, when's the height of the ball at 40? We could solve it by hand. I mean, that might be what they're expecting us to do here. If we had to solve this problem, I think we've done other problems like this. You know, you could move that 40 over here, make it equal 0. But if you're feeling a little lazy, I do think it's also important for you to know how there's maybe other ways to solve it. You could solve it by graphing it. So we have the y equals 40 on one side. And our other equation, the y equals negative 16x squared plus 70x plus 5. And we look for the point where those intersect. So that's one other method for solving that problem. So where is that equal 40 right there? At 0.453. Now that we might not be allowed to enter it like that. If I typed my equations in, right, the 40, oh, I didn't put a negative 16 there. Let's try that. See if that changes something for us. We have two answers now, right? Negative 16 t squared plus 70t plus 5. So we'll see if it allows us to even use those. We might have to use a different method to solve it. We got a 0.576 over on this point for the time when it reaches 40 and 3.799 for this point. And let's go back and take a look in Savas and see what we have to do. The height of the ball after approximately, the height of the ball will be 40 after how many seconds? I have two different answers. So use a comma to separate answers as needed. Round to the nearest, oh, so it's after. When you go after the 3.799, it actually is falling, so it'll be below. So I think that's just gonna be the round to the 10th. So that's one decimal place. So 57 would be a 0.6. All right. That's incorrect. Use a comma to separate the answers. The height of the ball will be 40 feet after approximately, I wonder if they want both of those answers and to the nearest 10th. I don't think the second one seems right. When this isn't right technically, because after the 3.8, it's not going to be 40 feet after that. It would have been before that. So I think that one, that's kind of an incorrect statement, it seems to me, because you got the ball coming up and down. There's the 40 line, if I call that the 40 line. And the height of the ball will be 40 feet after this, it's not. After this, it's, so just the wording on that, I don't like very well. All right, then they say, what about for 50? So if we go back over to that Desmos problem, it says, when you looked at what it was suggesting as to how to work that last problem, it was showing the quadratic formula. So, that if you do all of the arithmetic right, it's okay. But sometimes, so now I gotta pull this graph down so we can see that 50 line. The 50 here, what are our two answers for that? Let's use a different color here to write with. So for that one, we've got a 0.783 right there and a 3.592 right there. Let's go put that in Savas and see what it says for that one. Since we had to do the other one with both of the points, again to the nearest tenth, so 7, 8 would be a 0.8. And then 3.59 would be 3.6. All right, so continuing on with how they're doing the problem. And then it says, will the ball ever reach 130 feet? Well, this really is kind of cheating here by just doing it on the graph. You can do it if you want with quadratic, but what you're going to see here, and this is what they're doing with the quadratic, is you would get a square root of a negative if you tried to solve this as an equation. And so that would be the part that would be telling you that there's no solution. The other two, under the square root, you had a positive number giving you two different answers when it equaled. So anyway, the answer here is no, because the solution is negative, or well, definitely is no. We just saw that. But then the question would be, how would the equations work out? So both solutions of the equation are rational. No, they would be irrational. They'd have a negative in the square root underneath there. So it's not that one. The 130 is negative. No, then the 130, so it's got to be B, the one that says that you'd actually get solutions that are complex or that have a square root. These mean exactly what I was pointing out right there, that if you worked out with quadratic. So there you have it. And that's the last problem of lesson 2-6. So hopefully you're getting the hang of those discriminants, the quadratics, quadratic formula, and all those kinds of problems. Hang in there if you get stuck. Got the view and example, help me solve this, do extra problems on the bottom. Otherwise, you can always search out your own explanations on YouTube. Just don't give up.